Hello viewers, welcome to R22 YouTube channel. Today's topic is conditional probability. If E1 and E2 are two events in a sample space S and P of E1 not equals to 0, then the probability of E2 after occurring the event E1 has occurred is called conditional probability of the event E2 is given E1 and denoted by P of E2 by E1, and we define P of E2 by E1 equals to intersection of numerator and denominator by probability of denominator, or P of E1 by E2 equals to intersection of these two events in numerator by probability of E2. This is the conditional probability formula. Simply we can write it as E1 and E2 are two events with a probability and common terms in numerator, and calculating the probability with a denominator term is known as conditional probability. After occurring E1, then E2 will occur. After that we are calculating the common terms and probability of the denominator term is known as conditional probability. P of E1 intersection E2 equals to P of E2 intersection E1. These two are equal, and we can write the formula either this way or this way. Both are same. This is an example of conditional probability. Find a conditional probability. Maths and physics, intersection of maths and physics. Number of students who knows maths equals to 10, and common students maths and physics is 30. For calculating maths, we need to add 30 plus 10, 40. Number of students who knows physics is known as 20 plus 30 is 50. Number of students who knows maths and physics is 30. Intersection of these two subjects. N of M intersection P. Here M is maths, P is the physics. Intersection of these two common term is 30 equals to 30. Total students N of S equals to 10 plus 30 is 40. 40 plus 20 is 60. N of S equals to sample space is equals to 60. Calculating the probability of mass equals to number of favorable outcomes of mass by sample space. We will get the solution. For calculating physics, number of favorable outcomes of physics subject for the sample space. We will get the solution for probability of physics. Calculating the intersection of mass and physics equals to common term for both and with sample space. We will get the solution. Now P of physics by mass. This is the unknown term, unknown event for the known event. For these cases, we will calculate the problem by using this conditional probability. Probability of physics by mass. Taking physics is 30 by mass is 40. Then we will get the solution 3 by 4. For calculating the physics and mass, taking the intersection of these two terms in the numerator and calculating the probability of denominator term mass is equals to, we will get the solution by calculating some cancelling, and we will get the solution. For these solving cases, we use the conditional probability. Now another topic is important for one more question: independent in probability. It means that the occurrence of one event does not affect the occurrence of another event is known as independent in probability. It will occur separately without involving the another event is known as independence in probability. Knowing that one event happened gives no information about whether the other will happen or not is known as independence in probability. Two events A and B are independent if P of A intersection B equals to P of A and P of B. Here A intersection B is the probability of both A and B occur. P of A is the probability of event A, P of B is probability of event B. If If this equality holds, the events are independent. If this condition is satisfied, then it is called as independent event. If the condition is not satisfied, then it is not the independent event. Now we are going to discuss the example for independence and probability. We are using coin cases, coin tosses. Toss a coin twice. Twice is nothing but 2 times. Event A and event B. These two are 2 events of tossing the coin. First event is head. Second event is also head. Then calculating these two terms, multiplying together, we get 1 by 4. And the intersection of P of A intersection B is equal to P of A into P of B. 1 by 2 into 1 by 2 is 1 by 4. Since 1 by 4 is equal to 1 by 2 into 1 by 2, the events are independent. The condition is satisfied, so it is independent event. Drawing cards without replacement. First event is first card is ace. Second event B. Second card is ace. Intersection of A intersection B equals to P of A into P of B. This condition is not satisfied, so it is not the independence in probability. It is the dependent probability example. Because the first draw changes the deck of cards. It is not the independent. It is a dependent term. It will depend on the first card. So it is not the example for independence and probability. Addition theorem. It is important for 5 marks. If A and B are any two events of a sample space S and P is the probability function, then P of A union B equals to addition of probability of first event and second event and subtracting with common terms. State and prove addition theorem, or P of A union B equals to P of A plus P of B minus P of A intersection B. They will ask addition theorem in these cases also. Like this also they will ask for prove the addition theorem, and they will attach the problems for this theorem. Addition theorem is proved in 2 cases. In first case, let us assume that A and B are disjoint events. Then A intersection B equals to pi. P of A union B equals to probability of A plus probability of B. Union means we need to take addition. Since both are disjoint, from axiom of union, we can say that P of A union B equals to P of A plus P of B. This is the probability of A event, this is the probability of B event with a sample space S. S is the possibility of these two, all the favorable outcomes, and these two events together is known as adding union. Here we can say that A intersection B equals to pi, P of pi equals to 0, pi intersection equals to P of pi. There is no common element for event A and event B, so P of A intersection B equals to 0. Now we can modify equation 1. We can also write equation 1 as P of A union B equals to P of A plus P of B minus P of pi. So this is no value for P of pi. This is 0. For writing or without writing, there is no change. We will get the above equation as it is. So we can write P of pi equals to A intersection B. So P of A plus P of B minus P of A intersection B. LHS and RHS are satisfied. So this is the proving addition theorem in case 1. For case 2, let us assume that A and B are dependent events. Then intersection is equal to, first case intersection is equal to 0. For second case intersection is not equal to 0. This is the difference between first case and second case. We will take the A intersection B equals to 0 for proving the addition theorem. And for second case, we are taking A intersection B not equals to 0 for proving the addition theorem. So by using these two equal and not equal cases, we will prove the addition theorem. A union B can express as a union of two mutually exclusive events. For first one, we will take the axiom of union. For second case, we will take the mutually exclusive events condition. And A minus B and B are two events. Here A minus B and b minus a. This is the event of b. This is the event of a. And taking common is a intersection b. We'll prove by this diagram. P of a union b equals to probability of a minus b union adding with the second event b is equals to P of a minus b union means we will take a plus symbol and writing with probability second event as separated and taking it as first equation. After that P of a minus intersection a minus b means P of a only, no, so we will write a minus b as P of a minus b means we will take a intersection b because a intersection b is also the part of b, so we will write it as a intersection b. This is the second equation. By using these two equations we can write it as probability of a plus probability of b minus intersection term is also known as a union b, adding these total events. So the condition is satisfied. So addition theorem is proved. This is the example of addition theorem. Determine P of b by a and P of a by b complement. If a and b are two events with probability of a is 1 by 3, probability of b is 1 by 4 and the union is 1 by 2. For union we will write the addition theorem formula. For union left side right side intersection will come. For left side intersection means right side union will come. P of a intersection b equals to, we have union term, we need intersection value, so P of adding P of a, P of b minus union term. Solving by LCM and by solving we will get the solution of a intersection b. By using this a intersection b we will follow the conditional probability formula. P of a by b equals to intersection of these two terms in the numerator and writing the denominator term with probability. This is the conditional probability theorem. By using this we will solve the equation P of b by a equals to intersection of these two terms in the numerator and writing the probability of a denominator term as p by a. By substituting these values and cancelling we will get the solution. And P of a by b complement. For complement like b complement or a complement, we will subtract the actual term with a minus 1. Subtracting the actual term from 1, we will get the complement terms. For b complement we will write as 1 minus b. For a complement we will write as 1 minus a. A by b complement we will write as it is. Numerator and denominator intersection. Numerator and denominator intersection and writing the denominator with probability and writing the denominator with probability P of b. For calculating b complement we have one formula 1 minus b. After that calculating b complement we will substitute in formula. We will get the solution. This is the example of addition theorem. This is an important concept. Thanks for watching. Please subscribe to Survey 40 YouTube channel.